This is a walkthrough of the end behavior articles. So we're going to first start with the article, and then we're going to go to the exercise. So end behavior describes what happens to the function as x gets really big, approaching infinity. What happens to the y value? Right. So for example, here as x gets larger, f of x gets larger. And this example is f of x gets smaller, f of x gets smaller as well. So for the end behavior, you could say as x approaches infinity, f of x approaches infinity, and as x approaches negative infinity, f of x approaches negative infinity. So check out this understanding. What is the end behavior of g? Well, as x approaches infinity, as x goes towards the right side of the x-axis, f of x, the blue line, is going downward, so f of x is approaching negative infinity. So as x approaches positive infinity, g of x is going to approach negative infinity. Let's look at what happens when x approaches negative infinity. As x approaches negative infinity, watch my arrow, the y value is approaching positive infinity. So as x approaches negative infinity, g of x approaches positive infinity. So let's check if that's right. It is. Let's continue. Determining end behavior algebraically, we just need to answer two questions. As x approaches positive infinity, what does f of x approach? And as x approaches negative infinity, what does f of x approach? So let's look at the monomial x squared. For very large positive x values, which best describes f of x? F of x is a large positive number, or is f of x a large negative number? So what's negative a million squared? Well, it's a very large positive number. So f of x is a very large positive. Let's check. Yes, it is. For very large negative values, what best describes negative x? So let's say you have negative a million squared. Well, negative a million, negative times negative is a positive, so negative a million is still going to be a really large positive number. So let's check. Alright, so that's right again. So that means that as x approaches negative infinity, f of x approaches infinity. As x approaches infinity, f of x also approaches infinity. Let's look at negative 3x squared. For very large positive x values, a million squared is a really large number, times negative 3 is a really large negative number. Let's check that. Great. Now let's look at negative a million squared. Well, negative a million squared is a really large positive number, times negative 3 is a really large negative number. So in this case, as x approaches negative infinity and infinity, f of x is going to approach negative infinity in both cases. Now, let's look at an example, a positive x value. So a million. A million cubed, a million times a million times a million, is going to be a very large positive number. Okay? So let's check. Is h of x a very large positive number? Yes, it is. But what about a negative million? Well, negative a million times negative a million is a very large positive number, but then a very large positive number times negative million the third time is going to be a very large negative million. So a million cubed is going to be a very large negative number. So for this value, as x approaches infinity, h of x approaches infinity, but as x approaches negative infinity, h of x approaches negative infinity. Consider the monomial negative 2x cubed. For very large positive x values, what describes j of x? Okay, j of x is a large positive number, j of x is a large negative number. Well, negative a million cubed is a very large number, positive number, but times negative 2 becomes a very large negative number. And negative a million cubed becomes a very large negative number, times negative 2 becomes a very large positive number. Let's check. Boom, boom, right. Including. Now look at the degree, okay? So, the monomial and the leading coefficient affect end behavior. So if n is even and a is greater than 0, we have this end behavior. If n is even and a is less than 0, we have this end behavior. If n is odd and a is greater than 0, we have this behavior. And if n is odd and a is less than 0, we have this end behavior. So check out the article for yourself, explore it for a little bit. Alright, what is the end behavior of 8x cubed? As x approaches positive infinity, f of x is going to be approaching positive infinity, so it's one of either a or b. And x approaches negative infinity, g of x is going to be approaching negative infinity. So that's going to be option B, check. Yes, we're right. Anytime you need help, you can always click I need help, and it'll give you an explanation right here. End behavior polynomials. Now we know to find the end behavior monomials. What about polynomials? In general, the end behavior is the same as the behavior of its leading term. So here the leading term is going to be 8x to the 5th. So once again, positive infinity, negative infinity. That's going to be the end behavior, because this 8x to the 5th overpowers anything else. Alright, that's right. Once again, if you need help, check right here. Furthermore, for negative 6x to the 4th, this is going to be positive infinity, negative infinity, because this negative 6x to the 4th overpowers everything else. Why is... So the leading term affects end behavior because it just overpowers everything else. That's the best way to think about it. Okay, so let's do the challenge problem. Which could be the graph of negative 8x cubed? Okay, so this is going to overpower everything, and that means that as x approaches infinity, f of x is going to approach negative infinity, and as x approaches negative infinity, f of x is going to approach infinity. So that negative sign switches things up. Alright, let's check. We're right. And then for the end behavior, 2 minus 3x plus x plus 2 squared, what we'd have to do here is square things. So that'd be x squared plus 2x plus 4 times negative 3x. So the main thing is we'll have, though our leading term would be negative 3x cubed. So when you have negative 3x cubed, as x approaches infinity, f of x would approach a negative infinity. So we'd have it switched like this. Okay. Once again, if you need help, always use those hints. The explanations are quite good in my opinion. Okay, so that's end behavior polynomials article. So let's go to the end behavior of polynomials exercise. Okay, we have 2x to the 7th. Alright. So this is going to have, as x approaches, this is going to, a is greater than 0, so that means we're not going to have the change. X to the 7th is the leading coefficient, so as x approaches infinity, f of x approaches infinity, and as x approaches negative infinity, f of x approaches negative infinity. So we're going to have a positive, so f of x and f of x are going to have the same approaches for this one. Alright, so that's great. And which has the same end behavior? Once again, the leading coefficient is right here. So this is going to have a is less than 0, and for x to the n is an odd number. So that means that's going to have the behavior as x approaches infinity, f of x is going to, q of x is going to approach negative infinity. So infinity, negative infinity, so it's either b or c, and then as x approaches negative infinity, q of x is going to approach positive infinity. Because think about it, negative 1,000,000 to the 5th power, negative number times negative 4 is a positive number. So infinity, negative infinity, infinity. Great. Here negative x4 is leading coefficient, so for both of the cases I'm going to introduce you guys to limit notation. The limit as x approaches negative infinity of g of x is going to be equal to negative infinity, and the limit of g of x as x approaches infinity is going to be equal to infinity. Okay, we have negative infinity and we have infinity. They approach negative infinity. Oh, and that's going to approach negative infinity because a very large. So we're going to have negative infinity and negative infinity. That's going to be answer choice C. Good. So the last one here, 10x to the 8th power. Here our leading coefficient is 10 and our degree, and 10 is greater than 0. Our degree is even, so because of that we're going to be approaching infinity in both cases. So that's the only option there is going to be this one, but well, I guess you could have, so choose all answers applied. So which graphs have the same end behavior? So both A and D are going to be approaching infinity as x approaches both infinity and negative infinity. So check, great. So that's 100. That's your walkthrough. Have a good evening.